Hello, my name is Cihangir Tezcan. I'm an associate professor at Department of Cybersecurity at Graduate School of Informatics in Middle East Technical University, which is in Ankara, Turkey. So I will be your instructor in this course titled GPU Optimization of Advanced Encryption Standard. So I did my bachelor's in mathematics and master's and PhD in cryptography. And I'm currently the head of Department of Cybersecurity in Middle East Technical University, and also I'm the director of Cybersecurity Research Center. So before joining Middle East Technical University, I also worked at École Polytechnique Fédérale de Lausanne, and I also worked in Ruhr University at Bochum, which are both in Switzerland and Germany. So I teach many courses in the area of cybersecurity, and some of them are related to cryptography, which will be the main topic of this course. So the prerequisites are as follows. We expect general understanding of cryptography concepts and principles, but I will try to teach everything from the scratch. And we also require basic programming skills in C and CUDA, because this course is about CUDA optimization. So you need to know how to implement algorithms in C and CUDA. So most of the codes I'm going to show you are already available, so you can implement yourself or use the codes from there and modify and check if you're doing it correct and so on. So what you will learn? You will learn fundamental concepts in symmetric cryptography. So we divide cryptography into two parts generally. In the encryption case, we either use public key encryption algorithms or symmetric key encryption algorithms. And in the symmetric key encryption side, we divide that area into two as block ciphers and stream ciphers. So we will be focusing actually on block ciphers. So you will learn how to implement cryptographic algorithms, mainly block ciphers, and you will also learn how to optimize the block cipher on GPU. So in the first part, I will try to teach everything that we need in theory. So I will talk about block ciphers, then I will talk about Advanced Encryption Standard, shortened as AES. And every block cipher actually requires a mode of operation. So we will talk about mode of operations for block ciphers. So in the second part, with this knowledge, we will first implement our algorithm, Advanced Encryption Standard, in C and CUDA. These will be reference implementations, but then we will optimize it with CUDA and then check the encryption performance of our implementation, which will be actually world record. So this course provides fundamentals of block ciphers and mode of operations for block ciphers. As an example, we will focus on Advanced Encryption Standard. AES block cipher is responsible for the most of the world's encryption, maybe 99%, because we are using it daily, most of the time without knowing it. Every application that uses encryption, like encrypted messaging applications like Signal, WhatsApp, they use AES, or also Zoom communications. Those kind of voice and video communications are generally encrypted with AES. So this course also teaches how to implement cryptographic algorithms like AES in C and CUDA. And finally, this course teaches how to optimize AES on GPUs to obtain record-breaking performance. So it will be the fastest implementation for GPUs. So what you require? You need to install CUDA SDK to run the CUDA codes provided in the course. So you can either try a Windows or Linux operating system, but I found sometimes updating the Linux might cause problems with the display driver. So in the Linux case, you should be careful about the CUDA version and the display driver version. Generally, it is a little bit easier on the Windows side, but it is up to you. Our codes can run on any operating system as long as you have a CUDA capable device. So you need an NVIDIA GPU to run the CUDA codes. Thank you for your attention.